Okay, so let's jump right in. We're doing a deep dive today on how you get high-def video over long distances, specifically looking at this one device, the NTI ST-IPHD-LC-V4UK HDMI over IP extender.
Right. And our mission really is to unpack how this little box turns a huge headache. Running long, bulky video cables into a really elegant fix using the network cables most places already have.
Exactly. So the basic idea is you have a local unit at your source and a remote unit at your screen, and it just multicasts the signal over the network.
Hmm.
And for this model, the one with the UK plug, you're looking at about, what, $210? That feels incredibly cheap for bypassing professional video cabling.
It is. And the efficiency, it really comes into focus when you look at the distances it can cover. It handles full 1080p HDTV resolutions, which is pretty much standard for any professional signage.
Okay, but when you say distance, I'm thinking you must need some kind of special expensive cable. Are we really talking about nearly 400 feet on standard Ethernet?
We are, yeah. You can get up to 394 feet. That's 120 meters with a good KT6 or KT7 cable.
Wow.
And even with older CT5E, you're still getting 328 feet or 100 meters. That's the whole point. You're replacing these thick, expensive cables with cheap, flexible Catis wire.
And the quality holds up. I see it's HDMI 1.3 and HDCP 1.4 compliant. But what about lag? It mentions H.264 compression and latency under 100 milliseconds. Is that actually fast enough?
For its intended use, absolutely. For digital signs, video loops, movies, it's near real time. You wouldn't notice it.
But not for, say, competitive gaming.
No, probably not for that. But that's not what it's for.
Yeah.
And the really critical thing to remember is that the units have to be on the same LAN, the same local network. You can't push video over the internet with these.
Right. Got it. So how do we get from just one screen to a whole system, dozens of displays?
Well, that's where you move from a simple point-to-point connection, which is just one cable between the two boxes, to a point-to-many setup.
Which needs a network switch.
Exactly.
Right.
And the setup is, it's pretty much plug and play. The receivers are designed to just find the transmitters automatically as long as they're on the same subnet.
But let's push that. What if I want to run two different video channels, like two different sources going to two different sets of screens, all through one basic unmanaged switch?
You can't. You get, well, instant chaos on your network. The two signals are both trying to multicast, and they just collide. To do that, you need a smarter kind of switch.
Okay, so the source material says you need a managed switch, one that supports port-based IE 802.1Q fill-ban. For our listener who isn't a network admin, what on earth does that mean?
It just means you need a way to carve up the switch. A VLAN is a virtual local area network. Think of it like creating separate private tunnels inside the physical switch.
So each video source gets its own tunnel.
Precisely. Each transmitter gets its own VLAN, so its video stream runs completely isolated from the others. A standard unmanaged switch can't do that, which is why it can only handle one transmitter at a time.
That makes perfect sense. So if we stick to that single video source, just one transmitter, how many screens can we actually drive?
In a dedicated standalone network, and it really should be a dedicated network, the system can support up to 253 receivers.
253.
Yep. So you can send one video stream to a huge number of displays across a big facility. It's incredibly scalable.
So that's really the core takeaway here. This device lets you turn cheap, existing network wiring into a massive digital signage system, and you use VLANs to manage multiple video channels over hundreds of feet.
Right. And, here's the final thought on that. While the units themselves are super power efficient, the local one uses just 2 watts, the remote even less, the real bottleneck in a huge complex system isn't the 253 receiver limit.
What is it then?
It's the switch itself. The true limit becomes the backplane bandwidth of your managed switch. You have to ask, can my network hardware actually handle the massive data throughput of, say, 50 simultaneous 1080p video streams? That's where the real system planning has to start.